Okay, so lesson 12.4. And the title of this chapter is called Comparing Data Sets. And what we're going to focus in on today would be adding a value to a set of data. Or let's say adding a value to data points. So today's date is 6/6/16. Okay. Okay, so last year you guys should have talked about transformations. There was translations when you shifted things right or left, up or down. You had reflections when you flipped things. You had rotations when you turned things, either clockwise or counterclockwise. And then you had dilations where you either made things large or you made things small. Okay, and you guys did a little project on that. So that notion of transformation can apply to things like data sets. And so we're going to talk about something called a linear transformation. Savannah, they're gone. I haven't heard you hiccup. Yay. Oops. Okay, try this again. Hold on. Okay, so linear transformation is an operation performed on a set of data that can be written as a linear function. So if you remember back to linear functions, those are things that are predictable, that there's a constant rate of change. So I'm going to give you an example, and when that example basically is going to encompass what you guys are going to do on homework tonight, okay? What we're going to focus in on for us is adding something to our data. So today our focus is adding a value to the data. Tomorrow we're going to talk about multiplying something to the data, okay? And now this is a good question that got brought up, and it actually is part of your homework. Is it possible that we're going to actually add a negative number instead of increasing values, we would decrease values? And the answer is yes, because we can add a negative. That's the same thing as subtracting, okay? So we don't use the word addition, we don't use the word subtraction, we just say adding because I can add negatives, and that takes care of subtraction. So that's what we're going to work on today. So let me give you the example that they have in the book. So we have this guy, Tom, and he earns a certain amount every day. And that certain amount is most likely based on he gets an hourly wage. So based on how many hours he works, he gets a certain amount of money. So they kind of tracked him for, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 days. So over 23 days, they tracked how much money he made, and they just kind of listed it out. Then they said, well, what if for every day he worked, we gave him an extra $5? How would that affect the statistics that we could get about Tom? Okay, so what was interesting is how they organized the data, which was in a dot plot, which is kind of an interesting name because they don't always use dots in the dot plot, okay? It's kind of like a bar graph, kind of like a histogram, kind of not. And I think as soon as I do it, you'll understand. So what I'm going to do is create two. We've got the before he got the extra $5 per day and the after he got the $5 per day. So we've got Tom. Let's see, Tom's earnings. Before the extra $5 per day. And then Tom's earnings with the extra $5 per day. Okay? So, a dot plot is a line. It has a line to it. And let's see, we're going to count by ones. We're going to start at 40, and we're going to end around 60. So 40, 41, 42, 43, 44, 45, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. Actually, I probably don't need to go, well, no, I do. 54, so I'm going to have to extend this a little bit. 51, 52, 53, 54, 55, 56, 57, 58. That's about as far as I need to go. So what they did is they took his data and they just started marking it in. So he had 1 day of $40 as his pay. He had 3 days of pay at $42. Now notice what I'm going to do is every initial value that I have for a different amount of money, all going to be on a level. Okay, like I could draw a line right through the first level and it would be straight. And then the second level would be straight. So I'm keeping things so that each X is across from another X. Okay, I don't have like 3 X's taller than 2 X's. Or no, try that again. 2 X's taller than 3 X's. Okay, so we have to keep things really on par. Then he had 3 days where he made $44. And he had, let's see, 2 days he had $46. And he had 2 days where he made $48. And he had 3 days where he made $50. Come on. And 52, he had 4 days at $52. He had 2 days at $54. $54, excuse me. And then he had 1 day at 56. And he had 1 day at 58. Okay? So as I look at this data, what I can do is try to figure out some statistics on this data, okay? You know what, I'm gonna save the second and we'll do it on the next page because I wanna be able to show you all the statistics. Okay, so have you guys seen this before? This dot plot? Yeah, okay. So it's a great way to quickly organize data, especially again, stem and leaf plot, same thing when you have a large set of data. These when you have a large set of data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I have 22 pieces of data. So I want to figure out where the median would be. So I just take 22 and I divide it by 2 and I come up with 11. So what it says is that my median is going to fall between the 11th and 12th number. So we've got, wait a sec, do I make sure I have, no, I did this before. Yes, I did this before. Let me try this. I don't know why I have a problem counting today. We have 1 extra X I forgot to place in. At 52, there were 5 days he got $52. Sorry about that. Now, that changes our data to 23 numbers. If I divide that in half, I get 11 and a half. So when I have that says I have the number that comes after the 11th number is going to be my median, okay? So I'm going to count. 1, and I start from the bottom and count up. 2, 3, 4 from the bottom. 5, 6, 7, 8, 9, 10, 11, 12. So what I was able to do is discover the median. And that was at 50. Okay? All right, how about, is there any statistic that you can see real quickly from here? What else could I do?
The least number and the greatest number.
Okay, and that, what do the least number and the greatest number help me figure out statistically? What's that called?
The range.
Range. So we can do range from the least and the greatest. So our largest number was 58. Our smallest number was 40. And we get a range of 18. Okay, what else can I look for real quickly? Mode, yes. This is the easiest one with mode. What's the mode, Mia? Yeah, it's the tallest bar, right? So 52 stands alone. Okay, and let's see. So we got median, we've got range, we got mode. What are we missing? Mean. We're missing mean, okay? So here's how I use this to do mean. Kind of like what I used my stem and leaf plot. So for my mean, I've got one number at 40. I've got 3 numbers at 42. I've got 3 numbers at 44. I've got 2 numbers at 46. I've got 2 numbers at 48. Oops, sorry. I've got 3 numbers at 50. I have 5 numbers at 52. I have 2 numbers at 54. And then I have a number at 56 and a number at 58. And then I'm going to take all of those numbers, multiply them out, add them together, divide by 23, and I get the magic number of, trust me, 48.6. We will do one by hand, okay, but it's going to be a lot less, shorter set of data, okay? Now, standard deviation would be the last thing I would like to know about this set of data. So with standard deviation, remember what I'm going to do. I'm going to take that mean, 48.6. I'm going to subtract each of the data points from it, each of it. I'm going to take that difference, square it. I'm going to take all those squared differences, add them together, find the mean by dividing by 23 and taking the square root of that answer. So I'm not going to show that because I will show it just on the smaller set of data. So when I do that, my standard deviation equals 4.9. Okay? So now what's going to happen, because I don't get to work on a single screen, I have to go to the next screen. Now we're going to look at Tom's data if he did already get that $5 per day. Okay, so everybody good? Can we move? All right, so moving. So now this is going to be Tom's earnings with the extra $5 per day. Oh, sorry, I don't need that. So again, we have a number line. But instead of the number line starting at 40, I now add $5 to that, and I'm at 45, okay? So now my scale goes this way. 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, and then I need to go about 65. 61, 62, 63, 64, 65. Okay, then I put in my graph. I had 1 at 45, I had 3 at 47. I had 3 at 40, let's see, now 49. I have 2 at 51. Bless you. I have 2 at 53. I have 3 at 55. I have 5 at 57. Bless you. We have 2 at 59. We have 1 at 61. And we have 1 at 63. Okay? Now I'm going to perform the same statistics. Okay? So I'm not going to go through all the details that we did before. How we find a median, we're going to find the 12th number would be our middle. So our median is an easy one. 12th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it's 55. We did range. And our range would be our greatest, our maximum of 63 minus our minimum of 45, and we get 18. And then, I forgot what my colors were. Green. Mode. Was 57. And then we did mean. And I'm just going to tell you that mean, after adding up all those numbers and dividing by 23, we had a mean of 53.6. And then the last one, what did I do? Standard deviation, oh yeah. Standard deviation was 4.9. So I'm going to kind of flip back and forth to the two graphs. So physically, I just want you to look at the graph, the dot plot. Do you notice anything different about the dot plot? Looks pretty much the same, right? The only thing that's shifted are the numbers. Okay, so let's look at the statistics. So the original without the $5, he had a median of 50. His median with the $5 is now 55. Range originally was 18. Range is 18. Mode was 52. New mode with the additional $5, 57. Mean was 48.6. Now mean is 53.6. Standard deviation was 4.9. Standard deviation is 4.9. So what do you notice about the statistics?
Everything but the range and standard deviation jumped up 5 because I had 5 each.
Okay, so mean, median, and mode increased. Come on, you. By 5. Range and standard deviation did not change. And if you think about it, that kind of makes sense, because standard deviation isn't based on the mean, it's based on the distance from the mean. That's all we're looking for. Our mean shifted, so the distance between, with our values, between the new mean and each of the values, it's not going to be different. So the standard deviation makes sense. Range, the whole graph just shifted by 5. So that makes sense that the range would stay the same. And it makes sense that each of these other numbers just increased by whatever it was I added by. In this case, it was $5. So we're going to just jot a little note down here that for real values k, or a real value k, added to every member of the data set okay, which you could write it something like, let's see, I think they wrote it down weird. Did they write it down? No, they didn't. They're just saying, whatever you're going to do, here are the two things that happen. One, your mean, median, and mode now I'm going to use quotations here for increase. By the k value. Why would I put quotations around that?
Because if you're adding a negative,
Yeah, if you're adding a negative, you're going to shift left. You're going to go down by that k value. Okay, so increase is relative to what sign of the number that you're adding. So median, and mode increase by the k value, range and standard deviation do not change. Or we could say remain the same. Okay? So that's pretty cool. So now what we're going to do is an actual problem like what you're going to be doing on your homework tonight. And I gave you 4 because there are multiple things you have to do. But I'm going to suggest that you guys, you might want to try that line plot. It might help you out, and I'll show you how. I'll do it with the line plot. Okay, everybody good here? Yes? Savannah? Yeah, okay. So here's our set of data. We've got a group of data, and we are going to add 7 to each member in the data. So what I'm going to do is write out the data, and then I'm going to give you 2 different strategies, and you guys pick the one you want to use. It'll be interesting to see if you choose the same one that period 1 chose. I kind of agree with the one period 1 picked. So we've got 13, 5, 8, 12, 7, 4, 5, 8, 14, 11, 13, 8. Okay, so actually I'm not going to go any more than this. We'll just stop here, and I only want to do all the fix-ins once. So here's your 2 methods. Method 1. Work with the original then add 7 to mean, median, and mode. The other 2 numbers will stay the same. That's method 1. Method 2. Add 7 to each member of the data. Then find all stats. Okay? So we have 2 options. What we want to know is the data after we add the 7. We don't want to know Tom's original. We want to know Tom's after the 5. So do you think it's going to be easier to just go ahead and start with the original, find the 5 pieces of data, and then add 7 to the 3 key statistics? Or should I go ahead and add 7 to each of those numbers, then find their 5 key statistics? Which one do you think sounds simpler? Which one, Jake?
The first one.
First one? Who agrees with the first one? Okay, good. You're in line with period 1. I agree. I think this one's actually going to be the faster method. Okay, so I'm going to go to the new screen, and we're going to do the whole thing, doing it method 1, okay? So let me write my numbers again. Or actually, I'm going to do it this way. I'm going to just go ahead and start with my plot. So my smallest number is a 4. So, and my numbers are pretty small, so I'm gonna count by ones. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I think 14 is the top, right? No, 13 is the top, so that's good. So I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I'm gonna do my dot plot. So there's a 13, there's a 5, there's an 8, 12, 7, 4, 5, ooh, could be mode territory, 8, ooh, 2 modes, 14, 11, 13, oh, could be 3 modes, 8, oh. Mode stands alone. So that was easy. I can already get one statistic. Mode was 8. Okay? Hey, you. So next I want to look at how many pieces of data I have, and I'm going to figure out the median. So let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 numbers, and if I cut that in half, I'm going to get 6. So that means my median is going to fall between the 6th and the 7th number. So let's count from bottom up. 1, 2, 3, 4, 5, 6. Ooh, right here. Oh, guess what's between 8 and 8? 8. Okay, next. Oh, we could do range. That'll be easy. Or we'll wait. We'll wait on that. Let's do all the weirdos. Let's do mean. So I'm going to do mean over here because it's going to require a little bit more work. So let me show you how I use this to do the mean with this particular problem. So I have 1 4, I have 2 5s, I have 1 7, I have 3 8s, I have 1 11, I have 1 12, I have 2 13s, and I have 1 14. So I'm going to add those up, and I get 4, 10, 7, 24, 11, 12, 26, and a 14. So I just start grouping these. Remember, we kind of talked about this before, and I just start putting things together. So the first thing that stood out in my mind was here. That equals 40. So I like making that. So then I kind of look at these, and I'm going to put them together, and that's 21. These are going to give me 23, and then I have the 24. So then I just kind of group again, and I have 45. These add up to give me 63, and I add these together, and I get 108. So without a calculator, I can get a sum pretty quickly, even of 12 numbers. Now, mean's not done, right? Because what do I have to do next? I have to divide by how many numbers there are. And how many times does 12 go into 108? It goes exactly 9. So I'm going to put that over here. Mean is equal 9. Okay, now I have to do standard deviation. So standard deviation, again, I'm going to show you how I do this without a calculator until I get to a certain point when I have to use a calculator with standard deviation. So what I'm going to take is each number that's in my original set of data, and I'm going to go ahead and subtract it from 9. So I have a 4. So I have 9 take away 4, and then I'm going to square it. So that gives me 5 squared equals 25. And then I have 2 numbers that are 5. So 9 take away 5 squared gives me 2 times 4 squared, which gives me 2 times 16, or 32. And then I have 9 take away 7. And I'm going to square that. So I get 2 squared, and that equals 4. And then I have 3 numbers at 8. So 9 take away 8 squared. And I'm going to take that answer, and I'm going to triple it. So I get 1 times 3 is 3. And then I have 9 take away 11. And I'm going to square that, so I get negative 2 squared equals 4. And then I've got 9 take away 12 which is -3, and I square it, and I get a 9. And I have two numbers at 9 take away 13. So I get 2 times -4 squared, which is -4 squared is 16, times 2 is 32. And I'm going to cram this little guy down here. So I get 9 take away 14. I'm going to square that. So I get -5 squared, and I get 25. And then I just add them all up. So I get 25 and 25 is 50. I have 32 and 32 is 64. And then I've got, let's see, I'm just going to add. I've got 12 and 8. Oh, how lucky is that? 20. So that adds up to give me 70, and 64 is 134. Okay, now I take that sum of squared differences and I find its mean. So I take the 134 and I divide it by, I had 12 numbers. Okay, but that's not where I end. I need to take the square root of that. So that's really where I bring in my calculator, is doing that, because I noticed that 12 is not going to go into 134 evenly. So I have 134 divided by 12, and I don't change anything in my calculator, don't write it down, I don't round it. I take the square root, and I get this 3.3416561, because that's all the digits my calculator will hold. I round to the nearest tenth. So I get 3.3. So standard deviation is 3.3. So two of these numbers are not going to change for our final answer. So we're going to write final answer. Which two are going to be exactly the same? Oh, I didn't do one of them, sorry. What was the one I forgot to do? Yeah, I forgot range, because he's easy. So range was 14, take away 4, or 10. Okay, so what two numbers don't change? So my range is going to be same as the original range, 10. My standard deviation is going to be the same as my original standard deviation. What happens to my mode, my median, and my mean? Okay, how are they going to change? They're going to increase by what? So I'm just going to add 7 to those three numbers. So my mode is 15. My median is 15. My mean, oops, come here, you, is 16.
Miss Tardif wanted me to remind you that you're bringing your
Yes.
whole book.
Great, thank you. Okay, and that's it. Now, I know you're saying, that's it, that took a long time. I only gave you 4 problems. But the longest really was mean with multiple numbers and the standard deviation, okay? But remember standard deviation, you do have to use the calculator at the end, okay? All right?